Hello guys, welcome to this video. In this video, we are going to discuss the LeetCode problem 92, that is reverse linked list part 2. So basically here we are given a single linked list and two integers left and right. So we have to do is that we have to reverse the part between the left and right positions. So here we have linked list 1, 2, 3, 4, 5. The left is 2 and right is 4. So we have to reverse the part between this, that is 2, 3, 4. So our result will be like this: 1, 4, 3, 2, and then 5. So this part is just reversed here. So let's see how we can do this problem. So we have this linked list. And we have this as left and this as right. What we basically want to do is that we want the next of one's next to be this point, and next of 2 should be this node, right? This is our ultimate goal, that is one's next should be 4, then we'll have 4's next as 3, 3's next as 2, and then we should have 2's next should be 5, right? This is our ultimate aim. So since we have to just if we consider that we sort this thing up and this thing up, and we just have to reverse this part. So reversing this part becomes an entirely new problem. It's basically reverse linked list part 1, where we reverse the entire given linked list. So this is the problem 206, reverse linked list part 1. We'll just slightly go over it so we can get an understanding how we can solve this problem. So now let's reverse this linked list first, understand the intuition behind it. So what we do here is we consider a null pointer or null node. So consider we have a node here x, which is basically null. What we do is we consider this as the previous, this is our current, and we traverse whole through this linked list. We just do one thing, that is the next of our current is nothing but our previous, and we increase our current to 1 and our previous to 1. Basically current is equal to current next, and previous is equals to current. So how we write it is like while current is not equal to null, that is current is here, we don't do operations here, we store our this next of this current, that is 2's next, that is 3, this pointer, we store this pointer. So let's consider as 10. I'm not writing everything, but just to understand. So currents next, then what we do, we just make our currents next to currents next to previous, and previous is equal to current, and current is equal to temporary node. So what will happen now? First, this will be our 10 currents next, but our currents next will be previous. Our previous will come here to current, previous will come here to current, and current will be this next one. This is 10, right? This is 10, and then we'll just return our previous. So in the end, our previous will be here, our current will be here. Since current is null, we don't go inside this while loop. We'll just return this previous, and now our previous will be our head, right? Because this is the intended head. This is the last element of the original linked list. So we'll just return our previous. So its code will be written like this. Our current key will be initialized as head. We'll have a previous node which will be initially null. We'll start a while loop, and then we'll have a temporary variable as next and store its next pointer, and as discussed previously. We complete the code. So now in this question also we have the same scenario like this, but we have to do this thing here. We have to do this thing here, but we have two more things. We have to handle this part and we have to handle this part. So how we can do? So let's again have this linked list here. Okay. So since this is our left and this is our right. Okay. So first and first thing is that we have to identify these nodes, the left node and the right node. Okay. But previous, we can assume we'll see this example too, right? We'll get more idea. So your head is equals to 5. That is, there is only a single node. Left is equal to 1 and right is equals to 1. So if we can have a base condition like if our left is equal to right, then we will just return the head, because if our left is equal to right, consider this is our left and this is also our right. There is no point in reversing, right? Because this element will just be that only, because it's single element. So we'll just return head if our left is equal to right. If our left is equal to right, we'll just return the head. Okay, because we want the same linked list there. Okay, now our main thing starts. First we have to find the left node and then we have to find the right node. Okay, so to find the left node, what we'll do is we'll start a while loop, and we have what we have been given. We have been left. So now our left initially is 2 and our right initially is 4. So what we'll do, we'll just decrement left and right. So we'll have a while loop and we'll run this while loop until our right is greater than 0, and in this while loop we'll decrement left, and when our left is equals to 0, that means we have reached our left node, and we'll store that left node, right? That current, because we'll have a current variable which will travels through everything, travels through this entire array, entire linked list till we reach this right pointer, right node. Okay, so I'll explain how we'll write that in code. So we'll get this left node like this, and we'll also get this right node. So initially our left was 2. So uh, when we traverse at this node, our left will become 1. When we traverse at this node, our left will become 0, because we are decrementing our left here. And when our left will become 0, we'll store this node, this current node, in a new list node called as left node. So basically we'll have a new node called as left node, and we also have a node called as right node. So similarly, right minus minus will do, and we'll come till this, and we'll store this value in a right node. So now we have left node and also a right node. Okay, but in this problem, as we have identified before, what we also want this connection, right? This part, that is once next, and we also want this part, that is force next, because we will need to connect this, right? Because we are we will reverse this part, but we need this both connections. This next of this part will get as right node next. This is a right node, and its next is this part. So we'll get that easily, but we want this part also, right? So how we can get? It's easy. While we are traversing through this loop, while we are doing left minus minus and left is equal to 0, we'll also have one more condition, as if left is equal to 1. If left is equal to 1 means our this it will be this position, one position before our original left node. We'll do nothing, but we'll just add this, we can call it as a 2 left. Okay, 2 left. So this point is pointing to the left node, so to 2 left. So we'll, when our left is equals to 1 means at this position, we'll just put 2 left is equal to our current. Okay, so our 2 left will be the current. Okay, so now basically what we want, this is our linked list. So basically 2's next should be this 5, right? So this pointer. So let's consider a variable called as previous. Okay, previous, and this will be from right, equal to from right. So it will be 4 to 5, right? 2, and then we'll start a while loop. Our while loop will start, will terminate when our left node reaches this from right, right? From right, uh, because we want to traverse till here. So when it reaches this point, it should stop. So our left node is not equal to from right. I'm writing in shortcut. Okay. Now what we'll do is we'll have a temp variable, like what we did in the normal replace reversal. It will have the left nodes next, left nodes next. Sorry, left nodes next. So this will have this portion. Okay, and left nodes next, left nodes next will be nothing but our previous. How? Because we want this previous will this previous will be our left nodes next, new next. Okay, so now 2 will point to this 5, right? So how is our linked list now? We'll have this 1, this will be nothing, this will be 2, this will now point to, this will now point to 5, like this. Okay, and now we'll have our previous is equals to left node. So our previous, it was this previously, now it will be this. So our previous will point to 2 now, and our left node will now point to here, because we are going one traversal ahead. So our left node is equals to temp. So it will be here now. Okay, so now let's discuss the code. We have this left is equals to right, which basically is for the single, if we have both equals, then we just return the same linked list. Then we initialize this string, and we get our left pointer and right pointer using this while loop and decrementing the left and right integer values. We also get the 2 left node here. We then initialize our from right and previous nodes here, as discussed before. Then we have this while loop. This will be just for your last 3 traversals for 2, 3 and 4. For 2, 3 and 4 this while loop will work. Now at the end, if we have our since in our normal this traversal, our previous this position we came, this was our previous, right? This was our current when we went to the last node. This was the next base was this where my cursor is. It was your current, which was null. This was your previous. Now previous will be the head of the new linked list, right? So here also our previous will land here at this 4th. So our 2 lefts next, that is 1's next will be 4. So we have to do this 2 lefts next will be previous, and then we return our normal head. But in case if our 2 next is null, when will it happen? If our left value, this left value is 1, is given left is equals to 1. So this is our left. So our 2 next will be nothing but a null value, right? Because we will not come into this, right? We'll just go here, because our left value is initially 1. When we do 1 minus, so it will be 0, and we initially have our left node as base node, and our 2 left will be null. So if our 2 left will be null, we just return our previous value, because when we swap, when we reverse this, our 4 will automatically come here, and this will be our new head, right? So our new head will be a previous only, and we submit this question. So we solved this question. That's it for from this video. Thank you.